Hello friends, so welcome to Cadence tutorial. In this video I will explain about how to create any library and cell view for creating any schematic on Cadence Virtuoso. In previous video I have explained how to open jamming and putty for opening Cadence Virtuoso, so go to that video for opening Cadence Virtuoso. In this video now I am going to explain you how to create any library and any cell view. So first of all you have to go to file, then create a library. So go to new, then library, then in library you have to give the library name. So I am creating a library, that is Cadence tutorial. So this is basically my library name, Cadence tutorial. Okay, so this is my library name. Now click on attach to an existing technology library, then click on OK, and then you have to select any technology node. So I am selecting 180 nanometer technology node for my library, so it is GPTK 180. So you will find here GPTK 9045 or any other technology node, so you can select that, but I am selecting GPTK 118. Then press on OK. After that the library will be created. Now go to file and then new, then go to cell view, and in cell view now I am searching for that library, that is Cadence Tut. Now you have to select the technology file, that is basically now you have to create a cell view. So actually I want to so the ID versus VGS plot and ID versus VGS plot of NMOS. So I am giving the cell view name NMOS characteristics, then create on OK. So this will create a schematic of a NMOS. So this will open the workspace for Cadence Virtuoso terminal. So this is Cadence Virtuoso workspace. Now for adding NMOS and PMOS you have to instance that from GPTK 180 nanometer. So press I for instance, then go to library. So my library name is GPTK 180 for GPTK 180 for selecting NMOS and PMOS. So in cell you have to select NMOS, so click here NMOS. So this is the symbol of NMOS. So you can see here the length of NMOS is 180 nanometer technology, and this is width, finger width. So if you want to change this finger width and total width, you can change here, but the length remains same because you have already declared 180 nanometer technology library here. Then hide it, then drag it here. So this is the NMOS. Now for seeing its VDS versus ID plot, you have to give the control voltage to gate and source of this NMOS. So for that I have to bring the source voltage, that is VDC voltage. So that you will find in analog library. So go to analog library, and in analog library you will find VDC. So this is a voltage, DC voltage source basically. So set this voltage 1.8 volt because I am working on GPTK 180 nanometer, so I have to select a DC voltage of 1.8 volt approximately. So I am selecting 1.8 volt DC volt. Now press it here, then again go to analog library. So for instance I am using shortcut key I. Actually I want to show you some shortcut key for creating something. So this is the hotkey which you should use. Like for instance you should use I for wiring, you should use W for pin, you should P stage M property, you should use Q shortcut key for rotate, you should use R, undo U, copy C, fit to screen F and escape, that is exit. Okay, so this is some shortcut key. So now again I am going to press I, then in analog library I will find ground, so enter GND. So this is the symbol of a ground, then drag it. So after hiding it, this is the symbol of ground, then connect this get of NMOS with this voltage source, and the source of this NMOS will be connected with ground. So again I am going to copy this ground, so press C, then I am copying this ground here. Now again for wiring I am using W, I am going to wire it. Then the body of NMOS is connected with ground due to reducing the latch up phenomena and body effect. So again I am going to connect the body of this NMOS with ground. Then the drain of this NMOS should be connected with again voltage, DC voltage source. So just I am copying this BDC and ground, and then I will so copying I should use C, so this will copying these things. Now again for W, for wiring I will use W, so this will connect these. Now this is the schematic basically for NMOS characteristics. So I want to plot ID versus VDS and ID versus VGS plot of this NMOS. So for that, first you have to see that our schematic is correct or not. So go to this check and save option, then if your schematic will be correct, it will show here that no errors, schematic check completed with no errors, so it means our schematic is correct. Now I'm going to launch it. So in launch go to ADE L, and here again you should press on session because it will fetch license. So then again in this analysis go here, and then in transient analysis you should give some transient time, like I am going to, but I am here showing its DC and BDS versus ID plot, so I have to go to DC analysis. So in DC analysis go to component parameter, then select the component. So here basically the component is the component on x-axis. So actually I want to see the plot of BDS versus ID, so I have to select component of BDS, that is our drain voltage. So on select component, after clicking on select component you should go to schematic and then select that component. So this is our drain voltage. So after that go to this DC voltage, then click on OK. Again go there, and here you have to give some start and stop time. Stop time, this is not a time, basically this is the start and stop voltage for which you want to vary this BDS. So I want to see this graph from 0 to 1.8 volt. So I am giving the stop time 1.8, stop voltage 1.8, and the start 0. Then click on OK. Then again go to ADE L, then again right click on output section, here click on edit. Then from actually I want to see the output of that output current and the input voltage. So actually here output current is basically the drain current of this NMOS. So go to from design, then on design, you have to select this node. Actually, when we want to select, when we want to see the output voltage, then I have to click on the wire. Okay, but when I want to see current, then I have to click on node. So click on this node. Basically this is the drain of NMOS, so click on this node. So it will show the current entering into this NMOS from this drain, so it will show the drain current. Okay, now go to this setting output. So this is the drain current, click on OK. Then basically here the VGS, that is get to source voltage, is basically 1.8 volt. So it will enough for turn on this device. So this device will be turned on because VGS is above VTH. So VTH of this NMOS is basically maybe 500 to 600 millivolt, and our VGS voltage is 1.8 volt, which is enough higher than the VTH. So this device will be on state. Now so VDS, that is our drain voltage, will be vary from 0 to 1.8, and this is our drain current. So I will see the plot of this drain current. So again go to this ADL launch. Then sometimes some technology library already selected, so you have to unselect them. So go to setup, then again in model libraries. So you can see here GPDK 90, 180, 45 all are selected, so you should uncheck them. Only GPDK 180 nanometer or on which you are working should be check, other should be uncheck. So I am going to check only GPDK 180 nanometer, then click on OK, then run this simulation. So you can see this is basically the VD versus ID plot of NMOS. For changing its color or type or style, you can change from here. So style is basically I want to see it in solid because it will good look now. So if you want to change its color, you can also change from here. If you want to made it thick, so go to medium or thick. So you can see now it's broader than previous one. So this is the NMOS characteristics, ID versus VDS, ID versus VDS plot. Okay, now I want to see this ID versus VDS plot for various VGS. When we will vary this VGS, that is get to source voltage, then what will be the effect on drain current for a certain VDS. So I am going to see this. So for that I have to make this VGS variable. So press Q for changing properties. You should use shortcut Q. So press Q, then here make it variable. So making it variable, you have to give any name. So I am giving the name VGS for this DC voltage. So this is VGS. Now go to launch again. Check it first. You should check and save. Then go to launch. Then again in ADEL you should open ADEL and then set up those things. But I have already opened it. So close it. So actually this is our ADEL terminal. So now I am going to copy that variable. So our variable is basically VGS. So I am going to copy it from there. So in design variables, this menu, press right click here, then copy from cell view. You will get VGS. Now you have to give a value, that is anything. You can give it 1.8 or anything. So I am 1.8 generally, so I am giving 1.8 volt here to VGS. Then go to tools and then go to parametric analysis, because the parametric analysis gives you various plot on different parameter. Okay, so after clicking on parametric analysis, click here to add variables, then go on this drop down, then you will find the variable name VGS. So this is our VGS, the value is 1.8. now I want to see this VGS plot, sorry, VDS versus ID plot for different VGS. So I want to vary this VGS from 0 to 1.8 volt. So I am giving here 0 to 1.8, and in step mode I am going to make it linear. So this is linear steps. Then I want to show 2-3 plots. So for 0.4 make taking any step size, you will get that step durations for next plot. So 0.3 I am taking here. So this is 0.3, it means it is 300 millivolt. After 300 millivolt, 600 millivolt, 900 millivolt, 1.2 volt. So this will be the plot, that plot which you want to see. So after that, run this. So after running this, you will see some simulation time here. So it is 14%. So it is going to simulate. Now, so you can see here, this is VGS, VDS versus ID versus VDS plot for different VGS. So this is for VGS equals to 1.8 volt, this is for VGS equals to 1.5 volt, this is VGS equals to 1.2 volt, this is for 900 millivolt, I think. Yeah, this is for 600 millivolt, and this is for 300 millivolt. So taking a step size, uh, uh, taking a step size of 0.3 will give the VGS difference of 0.3, and for that VGS difference, this all plot we get. Okay, so I'm going to make it thicker again. Okay, so first I have to click on this plus button, then using control, press control and select all this. Okay, and change it style first, uh, style to solid, and then its width to medium. Okay, so now it is looking quite good. Okay, so this is basically NMOS ID versus VDS plot. So this is the NMOS ID versus VD characteristics. So ID versus VGS plot will be shown in next video, because it will it is already longer. So I'm going to stop now. Thank you.